Hi, hello there students. In this video we'll be learning about some super important properties about what we call quadratic functions. So you can look at this very nice beautiful parabola. Okay, so here guys we have this long list, okay, contains some properties of this quadratic function, and I have here to highlight that this quadratic function, okay, in standard form, it means it's written like from the highest power, which is power 2, then here comes the linear part, which is x to the power 1, and in this very tail we have this constant term. Okay, and these properties here we have, first of all, we have the leading coefficient. So what is the leading coefficient here is a, which is the constant multiplied by x squared in this case, as long as we are talking about quadratic. So the highest power is 2, so a is the leading coefficient, and for a here we have two cases: when a is more than 0 and when a less than 0. And in this list, guys, you will realize how this a leads the properties of this sort of functions, and maybe that's why they call it leader coefficient, because it's really decided. The sign of this decided many features, many properties of this function and its behavior. So first of all, the domain in general represents the set of numbers that you can plug in functions. Okay, so for this type of function, this sort of functions, the quadratic function, you are free to plug in any real number. You can take any real number and plug here in this function, and what you have to expect in return another real number. So you plug real, you get real. Okay, so the domain here is the set of all real numbers, regardless whether a more than 0 or a less than 0. Okay, for the vertex, guys, the vertex represents the vertex here is the lowest point in the graph when a is more than 0. So look at this, here is the vertex, something like this. Okay, so the vertex when a is more than 0 is the lowest point on this parabola. And when a is more than 0, when a less than 0, because the graph will be flipped upside down, so it will be simply in this shape. Okay, and here the vertex will be the highest point in the parabola, where in this case here, when a is more than 0, it will be the lowest point in the parabola. We will move into the sketch in the, not in x-axis, it's in the xy plane. So it will be like this when a more than 0, or like this when a less than 0. So it will be concave up when a more than 0, concave down when a less than 0. And what else, guys? Here we have what we call the axis of symmetry. So the axis of symmetry is the vertical line that split this parabola to two identical parts. So it's like, okay, splitting this here from the very middle, okay, to have like two identical, sorry, my line is a bit slant, but it's vertical, of course, vertical line. So here, this and this is the what we call the axis of symmetry. And for the axis of symmetry, it depends on the coefficients. Okay, if you have this function and you know already how to find a, b, and c, where b here is the x coefficient, a is x squared coefficient, and c is the constant term in this function. And here we have formula, and regardless a is negative or positive, so the axis of symmetry, okay, unchangeable, and the formula for this, whether a is positive or negative, is x equals, so x equals minus b, x equals, I will write it here, x equals minus b over 2a. And what we know guys, that any vertical line in the xy plane written as x equals, not y equals, because y represents horizontal lines. So the vertex here, or the axis of symmetry, x equals minus b over 2a. And for concavity guys, so concavity following the sign of the leading coefficient. It will be concave upward when a more than 0, and downward when a less than 0. Okay, concave up and down. So here it will be concave up like this when a is positive, and here it will be concave down, okay, when a is negative. And here guys we have what we call the only horizontal tangent, okay, the only horizontal tangent line for this parabola. So here take in consideration guys that there are infinitely many tangent lines for this parabola, maybe here, infinitely many, okay, and they have different slopes, okay, slopes sometimes positive, negative, but there is one single horizontal tangent. And the meaning of horizontal tangent, that tangent which is parallel to the x-axis, or has a slope of what? A slope of 0. And this very precise and unique tangent line is this one, okay? And the equation of this tangent is very special. It's y equals minus b over 2a. Okay, sorry, f of this, f of minus b over 2a. So it is the y coordinate of the vertex, okay, the y coordinate of the vertex. And for some reason this is mentioned here, so the only horizontal tangent, so the equation y equals, okay, the y coordinate of the vertex, okay. So what next? We have here the extreme. Extreme here, it depends and following the sign of a. When a is positive, then the extreme here will be this minimum value, and when a is positive, though, so then it will be like this, the maximum value. So it's like bottom and top, depends on a, whether a positive or a negative. And for the x-intercepts, and there's two of them, as you can see here guys, there's one here, there's one here. So in many cases there's two of them, okay. Not in all cases, but in many, yes. We will discuss that for sure. And for the y-intercept is 0 and c, and this is obvious. If you plug in 0 here and 0 here, then the only survival guy will be what? Will be this c. So 0c is the y-intercept, which is the point where this parabola passing through the y-axis, okay. And it's 0c regardless what is a, whether a positive or negative, 0 and c. So the coordinates here 0 and c for the y-intercept. It is 0 and c. 0c and here 0c regardless what we know about a. Okay. And here the range. The range in simple words is the set of all output. Yeah, it means, look at this graph here, for instance. In this graph, I can recognize that the domain is something from this point. I don't know what is this point to this point. So this is this part of the x-axis is the domain, okay? Okay, and the range, you can see that the range is the set of all outputs, which is this part, okay, on the y-axis. Okay, so here the range follow affected by A, because when A is more than 0, the range is something, and when A less than 0, the range is something different. So look at this here. I will do this and this. So if A is positive, then the parabola might be like this. So the range will start from this point on the y-axis, which is the y-axis of the vertex, to infinity, okay? To infinity. And when the graph like this, then the range will be absolutely different. From minus infinity to this point, which is the y-coordinate of the vertex. So what is the y-coordinate of the vertex anyway? So the y-coordinate of the vertex is this one. So the vertex itself, we know that the vertex is minus b over 2a, and f of this guy, f of minus b over 2a, okay? And okay, if a more than 0, then the range will be from this point, which is minus b over 2a to infinity, f from this point to infinity. And if a less than 0, then the range will be from minus infinity to the point, to the y-coordinate of the vertex, which is like this, from minus infinity to f of minus b over 2a. And you are free here to close the interval, and here it will be from f of minus b over 2a up to infinity, okay? Up to infinity. And the good news, guys, the good news, and you have to make sure that the interval from the infinity side and minus infinity side is open, not closed. And the good news that all these rules is given here in the second table on this file, and this file is accessible. You can download this file, and highly recommend you to download, print out, solve, and enjoy, okay? So here, the range when a more than 0, I have very nice description here. The range, all values, okay, all values greater than or equal to the vertex value, which means the y-coordinate on that vertex. And here it's the all values that, okay, less than or equals to the vertex value or the y-coordinate of that vertex. And when it comes to increasing and decreasing, it depends also on the value of a, whether a is positive or negative. This is absolutely affect the intervals of increasing and decreasing. So when a is more than 0, the graph will be like this, and you can easily recognize that here the graph is decreasing from minus infinity to this point, which is the x-coordinate of the vertex. Then it will change to increasing from this value to infinity. And when the graph is like that, it's super easy to recognize that this function is increasing from minus infinity to this value here, and then it will be decreasing from this value to infinity. So you can recognize how this really follow the sign of the leading coefficient A. Again, guys, fortunately in the second table all these details are mentioned, you can rely on them. Okay, so here we know the increasing and decreasing. It's really following the sign of the leading coefficient. And yes, last on the list, guys, I have what we call the end behavior. And what is the end behavior in general? The end behavior means the function behavior when x goes very, very large or very, very small. It means that the limit when x goes to infinity or minus infinity. So let us have a brief look here. So when a more than 0, then the graph will be something like this, okay? And we can realize that whether x goes very, very extremely big, very, very extremely large, the function itself in both cases going up to infinity, okay? And this is, here we have exactly the opposite. So here a is negative. So in both cases, whether this function, whether x goes very large or very big, the function is going to minus infinity. So this is follow the sign of the leading coefficient a. And here, guys, all the rules or the rules you need. And look at this. So here we have the domain. We are, for the domain, guys, we are using this R. They call it fancy R. Okay, it's not easy to do by hand. So there's like a lot of duplication here. But to make it very recognizable, we can make normal capital R like this. And you have to sprinkle this here. So it's like you double this side of this fancy R. And it's from minus infinity to infinity, or you can write this fancy R. Okay, and for the vertex, guys, look, the vertex, you know, the vertex is a point. And that point has two coordinates, x coordinate and y coordinate. The x coordinate of the vertex is minus b over 2a. And the y coordinate is f of that minus b over 2a. It's same for both. And look here, guys, we have this graph, this very nice graph. When a here, remember that what we have to the left when a is positive, what we have to the right when a is negative. And here, guys, I have the axis of symmetry, which is x equals minus b over 2a, regardless the sign of a. And for concavity, guys, it concave upward, downward. So here, guys, we have what we call the only horizontal tangent is y equals the x coordinate of the vertex, and regardless whether a is positive or negative. And here, guys, I have extreme value. And for extreme value, you know, guys, it depends on the value of a, whether a is positive or negative. It will be minimum when a is positive, and it will be maximum when a is negative. And this minimum occurs when x equals minus b over 2a. Okay, and for the y-intercept, we discussed that it's 0 and c. And here, guys, we have the range when a positive, when a negative. And here we have the intervals of increasing and increasing. So when a positive here, to the right when a negative. And here, guys, we have the interval of decreasing when a positive and when a negative. And here we have the end behavior. When a positive, we have agreement before that when a positive. So, and because the graph is simply like this, it goes up to infinity regardless whether when a is positive. And where a is negative, then the function in behavior going to minus infinity. Okay, so here when x goes to infinity, it means when x goes very, very large, the function is going to infinity. And when x goes to minus infinity, here it means that the function, the values of x goes very, very, very small. In both cases, the behavior of the function is the same, going to infinity. And here, when a is negative, regardless whether x goes to infinity very, very large or x goes to minus infinity very, very small, in both cases, you can see these tails, they are going down to minus infinity, okay? And it's the time, guys, for practicing that. And for this purpose, I already suggest 15 different problems. We will discuss them, okay, to the slightest detail, okay? Okay, guys, this is question number 1, and let y, sometimes we call it f of x, it's fine, equals x squared, okay, minus 4x plus 3. So what I need here, I need to recognize 3 things. I need a, b, and c. So what is a here? A here is 1, is the leading coefficient. And what is b? b is the linear part, which is minus 4. And c here is the constant term, which is 3. And to be honest, these 3 guys reveals a lot about how this function behaves, okay? So I will start with the first. This is very trivial, the domain. The domain, like, it's from minus infinity to infinity, or this fancy R. And I told you before, guys, how to write this R, especially when you like me, I have like maybe one of the worst hand writing. So you can make capital R and you will add this little here, this little, I don't know, little what. Just we duplicate this left side of this R. Okay, it will be very ununderstandable that this is not the normal capital R that people use. It refers to the set of all real numbers. Or you can write this beautiful interval from minus infinity to infinity. So you have option to write this or this. Okay. And so this is for all problems. All problems, no exception. The domain is the same, which means in reality that you can replace here x by any number. You can replace x by any real number. And what you have to expect in return is a number. So you plug in real number, you will get a real number. So this is the meaning of the domain, to be like from minus infinity to infinity. So, and here, guys, we have the vertex. So for the vertex, guys, the vertex here is given, but I will tell you how to find this minus 2. So first of all, remember that the vertex is a point. And this point contains 2 coordinates, the x coordinate and the y coordinate. Okay, for the x coordinate, so the point will be like this, minus b over 2a, okay? Along with the y coordinate, which is f of this guy, f of minus b over 2a. So I told you before, we have a and b and c as well. So b is minus 4. So minus 4, if you replace here, so it will be like this. It will be minus b, it means 4 over 2, which is, 2 over 2a, a is 1. So minus b, it will be 2, right? So it will be 2 and f of 2. No, it will be minus 1, because, yes, let me double check here, please. Minus b over 2a. So 2 times a, 2 times 1 is 2, yes, f of 2. Okay, guys. So it will be 2 and f of 2. So it is like this simply. You can just replace, you have a and b. It will be 2 and f of what? F of 2, like that. And when you plug in 2 here in this function, you can use your mental math or you can use your calculator. So it will be like this, 2 and minus 1. You can give it a try. You can just plug in 2 here, then you will end up with minus 1. So we know, guys, what is the vertex, and the vertex will be helpful to sketch. Sketch means to have like not very accurate graph, but instead we have like a graph that like help us, guide us to find the rest of properties. So 2 and minus 1 for me is here. For instance, it's fine. And what I know that this function is concave up because a is positive, a is 1. So it will be somehow more or less like this, okay? So, okay, guys, here the vertex is revealed clearly, which is 2 along with minus 1. So, okay. So let us move to these properties. So we have the vertex. So the x, when it comes to x-intercepts, how to find the x-intercepts? Okay, here I will rely on what we call factoring. I will make it equal 0. X-intercept means that x squared, this x squared, okay, x squared minus 4x plus 3 equals 0. Plus 3 equals 0. I already discussed this factorization like in another video. You can find it easily. So how to factor this? It will be x minus 3 and x minus 1. So it will equal 0, which means x equals 3 or x equals 1. So we have 2 x-intercepts. So it's 3, okay, it's 1 with 0 and 3 with 0. So 3 gives me the x-intercept of a 3 and 0, and here it gives me 1 and 0. So it means that this graph is not accurate because this seems negative and this seems positive. It's fine. I told you before, this graph, it's not accurate, but it will guide me only, okay? So look at this here. The axis of symmetry. And as I told you guys, the axis of symmetry here has a formula. It will be x equals minus b over 2a. In other words, it's x equals the x coordinate of the vertex. So what is the vertex? 2 minus 1. What is the x coordinate of the vertex? 2. So it's simply x equals 2. And if we look at this, guys, you can easily find that the line passes through this point, split this vertical line, split this parabola for 2 identical parts. So it will be x equals 2, which is the x coordinate of the vertex. The concavity, as long as a is 1 and a is positive, then this concave up over, or concave up along, okay, for the whole real number. So along up over minus infinity to infinity, or you can write this fancy r, or you can simply say it's concave up or upward. It's up to you, okay? And here the horizontal tangent, and as I told you guys, there is one single horizontal tangent line for this parabola with the slope equals 0, this tangent line, okay, which is y equals the y coordinates of the vertex, which is 1 here. So here the only horizontal tangent line is y equals minus 1, okay? And here the extreme, look at this graph, please. This graph concave up. So here we have minimum value, okay? And this minimum value occurs when x equals 2, obviously when x equals 2 And what is that minimum value? That minimum value is -1. And this is super important to understand. So the extreme, I will first of all classify this extreme to minimum. It's minimum, okay, when or at x equals to equals or equal to -1. So here, guys, please, we have to distinguish between the occurrence of that minimum. It occurs when x equals -2 or at -2 and equals to what? To -1. So see how this vertex really super important, okay? Because at this vertex we have the minimum value ever for this parabola, okay, or at -2 and equals to -1. What next? I have here the y-intercept, and the y-intercept is 0 with c. And we have already listed here, we have c. What is c? c is 3. So what I know that this parabola passes through the point, okay, of 0 and what? 3. 0 and c, which is here 0, 3. Okay, again, guys, I know that this graph is like not accurate, but the purpose again of this graph is to guide me finding the properties, okay? So here the range. The range means the set of output. So we can realize that all possible outputs started from this point. Look at this. So it started from this point on the y-axis and goes endless to infinity. So what is this point here? It's the y-coordinate of the vertex. So it's from -1 to infinity, okay? So from -1 started the range here, started closed interval, and I have here to insist on that. It means that -1 is a part of that range and endless to infinity. So let me break this down. It means that whatever you plug in this function, any number, then the output will be something from in this interval from -1 to infinity. So there is no way to plug in a number in this function and you end up with -5 because -5 not in this. This is the meaning of the range, okay? And here increasing interval. So this function here, look at this. This function obviously increases here. This portion of the graph is increases, and it's from 2 to infinity. So it means that from 2 to infinity, this function is getting bigger and bigger. So the interval of increasing here is this one. It's increasing from 2 to infinity. You can close the interval here, or you can simply keep it open. So it's optional to close or open the interval from the side of 2. And the increasing interval, the decreasing interval. So this function is decreases, as you see here, from -infinity decreases to, please, to 2, not to -1. We are considering the increasing and decreasing with respect to the x-axis, not to the y-axis. So the intervals of decreasing from -infinity to what? To 2. Here open interval, and here optional, whether you make it like this or this. Okay, you will understand this maybe later, but for the time being it's optional to keep the interval from the side of 2 open or closed. The end behavior, we can depend on this graph. Look at this graph. Regardless x going very, very big or very, very small, the function in both cases going to infinity, right? And we have agreement before, when a is positive, right? When a here is positive, then whether x goes very, very big or very, very large, the function is going in both cases to infinity. But to visualize this and make it easier for you to understand, look here. When x going very big like this, the function itself going up, and when x going here very, very extremely small to minus infinity, then the function going up to infinity. So in both cases, this function or these tails going up. So what we can write, there's two different ways. One of them to write limit sign. So limit of f of x when x goes to infinity equals infinity, and here limit when x goes to minus infinity, then the behavior of this function goes to infinity as well. Or you can write it like that, as x goes to infinity, two dots, then f of x goes to infinity, it's fine, and here as x goes to minus infinity, then f of x goes to infinity as well. So whether using limit or this long story, both are fine. Okay, what next? Next I will move on straight forward to one more practice. Here guys, I have the second practice where y equals x squared plus 6x, okay, plus 8, and here we have a, b, and c indeed. So a is x squared coefficient, which is 1, and remember 1 is positive more than 0, this will guide us a lot. And b here is x coefficient, which is 6, and c here equals 8, the constant term. And as I told you before guys, this domain part not interesting because it's always from minus infinity to infinity, or r. If you don't know how to write this r, you can write capital R with duplication here for this part. Okay. And the vertex given minus 3 and 1. How come? Because the vertex formula is like this. It's minus b over 2a. And f of this guy, f of minus b over 2a. Okay? And it will be, what is b? b is 6. Minus b minus 6 over 2a. a is 1. So it's simply minus 6 over 2, which is minus 3, along with f of minus 3, okay? And the point here, of course you can use your calculator to find f of minus 3, but even if you use your calculator, you have to write it in correct way, even if you are using your calculator for this purpose. So I will write it here. So y or f, it's fine. It's x squared. It means minus 3 squared plus 6 times minus 3, then plus 8. What I can do here, I can guarantee you guys, this is massively incorrect. Do you know where's the incorrect part? And here where majority of students make mistakes here. This is minus 3 squared. What I meant minus 3 squared. So the squared not for the 3 and the minus as well. And how to make it like that? We need here parentheses. And what will happen if you don't put these parentheses? Simply the answer will be incorrect, okay? So that's why guys, you have to take care even if you are using your calculator. And the answer here, it's written before -1, it will be -1. So guys, what we have here -3 and -1 is the vertex, so the vertex is fine to be here. Okay, y-intercept is 8. I don't know, but I realize that this is really very narrow. Again guys, this is not accurate, but the purpose of this sketch is to guide me to find the rest of properties. So here guys, I have this vertex, so allow me just to clear this. I will give myself more room here, and please keep this plug in your mind. And the vertex here again guys is -3 along with -1. Okay. Okay, guys, sorry for this graph, but the graph is somehow like this, but it's smooth without corners, without shapes. So -3 -1 here, and we have like -3 -1. We have here x-intercept, y-intercept at 8, and it's like that somehow. Okay. It will be more or less like that, guys, with this beautiful vertex here, okay, at -3 -1. So here, guys, I reach this point where I have to find the x-intercept, okay, and based on this graph again, this is like not a graph, this is sketch, which is not that much accurate, but it's very nice maybe to guide us. So, and the function here itself is x squared plus 6x plus 8. So I will assume that to find x-intercept, that x squared plus 6x plus 8 equals 0, and this is factorable, of course. Again, guys, there's a video discussing already this matter, how to factor things so easy. Equals 0, it will be x plus and x plus 4 and 2, 4 and 2. Then I have two x-intercepts, I will write them here. So x equals -4, we have to change the sign, and or x equals -2. So we have -4 with 0 and -2 with 0. So we have two x-intercepts here, guys. And when it comes to the axis of symmetry, remember that the axis of symmetry is, it's x equals what? X equals -b over 2a. Again, what is this? This is the x coordinate of the vertex, so it will be x equals -3. And if we have this vertical line passes through -3, you see, sorry for this bad graph, but this line will split this parabola for two equal parts somehow. Okay, that's why we call it axis of symmetry. Here the concavity, concave up over all real numbers, or the set of all real numbers, or simply we can say concave up or upward. Okay, see the only horizontal tangent, and as you can see, guys, here we have horizontal tangent, and this is unique. And what is that horizontal tangent with the slope equals 0? It will be y equals the y coordinate of the vertex. So what is the y coordinate of the vertex? -1. Okay, and here the extreme value, as long as this curve concave up, we have bottom point here. If you look at this, guys, sorry, if you look at this here, we have bottom point. So this is minimum value occurs at x equals minus 3, and the minimum value itself equals to minus 1. So there's two things here to highlight. I will classify this to minimum value at x equals minus 3 equal to f of minus 3, which is obviously minus 1, which is basically the vertex. Say it occurs when x equals minus 3 and equals to f, the image of minus 3, which is obviously minus 1. Y-intercept, it's trivial, it's 0, 8, which is 0 with c. It's 0 with c. What is c here? C here is 8. Okay. The range, it's from, okay, the range started at the vertex to infinity because it's concave up. So the vertex is here, the y coordinate of the vertex here, and it's going to infinity. This is the range, which is the set of all output, okay? So the vertex here started from the y coordinate of the vertex, which is minus, again, what is the vertex? Minus 1, yes, 3 and minus 1, minus 1 up to infinity and closed at minus 1, open indeed from the side of infinity. Here the increasing, so this function is increasing, and obviously you can see here, guys, that this function is increasing here over this sub-interval from the x coordinate of the vertex to infinity. Please don't ever say that it's increasing from minus 1. No, we are taking x in consideration. So this is increasing, okay? Increasing, so the increasing interval is from minus 3 to infinity. Please, not, no, don't ever do that. Not from minus 1 to infinity, okay? This is not the increasing, this is the range. So please don't write this. And decreasing, the decreasing interval. And look at this graph here, it's decreasing here, 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 here. So decreasing from the minus infinity till minus 3 when it's reached like its minimum. So from minus infinity, open interval indeed, to minus 3 closed. Honestly, minus 3, you can make it closed interval or open. It's up to you. Yes, it's optional, whether closed or open. Both are correct. And here, last on the list, I have the end behavior. You know, look at this graph. The function tails, it's like double-tailed here. We have tail here, we have tail here, sorry, and these both tails are going to infinity. So already this is mentioned here on the list because a more than the leading coefficient is positive. So we write it like that limit f of x when x goes to infinity equals infinity, and same here, limit f of x when x goes to minus infinity equals, so it's infinity whether x goes very big or goes very small. So regardless x going very big or very small, this function has the same behavior at infinity, at minus infinity as well. And I will move into the next example. Here I have y equals x squared minus 10x plus 21. Then we will find this list. And the most important thing here, guys, and what makes this video useful for you, that you can pause the video wherever you like. You can move in to the problem where you realize that you need more explanation. And the PDF is available. You can entirely depend on that PDF. You can print it out, solve, give it a try. That's it for that, okay? So look at this, guys. Yes, here first of all the domain, this R or this R, or I can add this capital R with this line just to distinguish this real numbers from the normal capital R we know. So here, guys, we have A, B, and C. Look at this beauty. A equals 1, which is positive more than 0, and B equals minus 10, where C equals 21, as you see, guys. So here the vertex, so the domain, we are done with the domain. The vertex is minus B over 2A, and f of this creature of minus B over 2A, so which is indeed minus B over 2A. B is minus 10, with minus will be 10 over 2 simply, which is 5, and f of what? F of 5. How to find f of 5? You have f already. Look at this, x squared minus 10x, but you have to write it correct in the calculator, so it will be f of 5. How to find f of 5? F of 5 like that. F of 5, okay, I will write it here. F of 5 equals, of course, 5 squared. 5 squared with or without brackets, it's fine because it's positive already. Then 10 times 5, okay, plus 21, and we have the result. The result here is given already as minus 4, okay, equals minus 4. You can double check that if you like. So this is how we find the vertex. So it is 5 along with minus 4, and we have here the vertex of 5 and minus 4. I will make it here, it's fine. So I will assume, this is 5 and this is minus 4. So now we can sketch, which is like a brief graph without details, without that much of accuracy, okay, guys. And the y-intercept here is mentioned 21. So I assume this to be somehow like this, okay, plus or minus, okay. And somehow this is 21. Again, guys, this is not about reality. The purpose of this sketch is to guide and help me to visualize the problem. And for x-intercepts, I will take this function, which is x squared minus 10x plus 21. X squared minus 10x plus 21, make it 0. If you have any weaknesses in how to factor, I have a video here in this playlist. It will guide you step by step through factorization to make it piece of cake for you and very, very easy to handle. So x and x, minus and minus, 7 and 3. So we have two x-intercepts, okay, of 7 and 3. So x equals what? 7 or x equals what? Equals 3. You know that we have to switch the signs. Minus 3, it will be 3. Minus 7, it will be 7. So, and the solutions are here already, but I just mentioned the details, how to find the zeros. Factorization is one reliable method you can implement here. And again, the axis of symmetry. And look at this beautiful vertex of minus 5 and 1. And this vertex reveals a lot, in fact, because whatever here is the axis of symmetry. So it's x equals 5, right? So x equals 5, if you like it in details, so x equals minus b over 2a, or x equals the x coordinate of the vertex. Concavity, obviously this is concave up, that's it. Okay, the only horizontal tangent line, which is y, equals the y coordinate of the vertex. So what is the y coordinate of the vertex? Obviously it is minus what? Minus 4, because this is the horizontal tangent which passes through the point 5 and minus 4. So it will be y equals minus 4 indeed. Okay, and here the extreme, look at this point. This point is bottom, right? So, and this minimum value at x equals 5 equals minus 4. So the question is where this extreme happened. It's at x equals 5 equal to f of 5, which is minus 4. It means that if you select any real number and you plug in this function here, this quadratic function, so the smallest point, the smallest outcome ever you will have is minus 4, and that minus 4 occurs when x equals 5. That's it. Okay, y-intercepts, this is 0c, which is here 0 along with 21. Okay, look at this function. If you plug in 0, 0, then it will be 21 by the end of day. Okay, here the range started from the minimum value up to infinity. What is the minimum value? The minimum value is minus 4, right? So the minimum value is minus 4 included to infinity. This is the range. Okay, and the increasing interval, I will clean this. So it's increasing here over this sub-interval here. Okay, so this increasing not from minus 4, please, because we are taking increasing and decreasing with respect to x. So the increasing started at minus 5, sorry, up to infinity. Okay, so it's increasing over this sub-interval, whether you like it, write it like that, sorry, you can make it like from 5 to infinity or open interval 5 to infinity. It's fine, both are correct. And decreasing otherwise, so it's decreasing from minus infinity, going there, decreasing till we reach what? Till we reach that beautiful 5. So it's decreasing from minus infinity to 5 open, or from minus infinity to 5. Both are correct when it comes to increasing and decreasing. Okay, the end behavior, whether x goes to infinity or to minus infinity, the tails of this function, okay, this is very special creature with two tails, going to infinity, going up. So whether x goes very big, the function going up, very small, the function going up as well. So how to express that? I can use the language of limits, and this is something later or sooner you will be familiar to. So it's like that, limit as x goes very large of this function f equals infinity. Same wise, limit when x goes extremely small, this function f goes to infinity. Again, this creature with two tails, they are going to infinity in any way. Okay, and here guys we have this very nice, beautiful quadratic function. We will find these properties. Yes, here guys, in this function we have the value of a, and a here equals minus 1, where B equals x coefficient, which is 2, and C equals 8. Okay, so the domain is from minus infinity to infinity, or this fancy R, or I can add this capital R with this extra touch here. Okay, so the vertex and the sketch. The vertex here is given minus 1 and 9. Okay, so how come minus 1? So the vertex is like that. It's minus B over 2A, and f of this guy, which is minus B over 2A. And if you just plug in, you have A, you have the numbers, you have everything you need. So it will be 1. And if you plug in 1 in this function using your calculator, okay, then it will be 9, okay? If you plug in 1 and the answer was something different from 9, then there's something wrong. Maybe the way you write this in your calculator. Okay, you have to master this small detail to how to write things in calculator. Okay, I will do it here and I will clear it, then you can. So it's 1 minus 1 squared. I prefer this brackets, and minus here is not included. Okay, plus 2 times 1, and here plus 8. If you plus 8, yes. If you plug it like that in your calculator, exactly like that, then the answer undoubtedly will be 9. Okay, I will clear this. I need more room. Okay, guys. So I know now the vertex. I know this function is concave down. And minus 1 and 9, it's a bit high here, okay? So if this is minus 1, again, guys, the purpose of this not to graph this like in a very accurate way, but the way is to give me something to visualize this parabola. So minus 1 and 9, I will assume minus 1 here and 9 to be here, okay? And this is somehow going like that, and okay, maybe like, okay, maybe like this. Okay, guys, this is fine. So this is minus 1 and 9, sorry, this is 1 and 9, sorry. So again, this is 1 and 9. This point, the vertex here is 1 and 9. I have very big miss here. So again, 1 and 9, 1 and 9 here. So 1 and 9. Okay. So so this is not y, this x-intercept. So I have now the vertex and brief sketch, okay? As you see, guys, I have the sketch here. The x-intercept, I will take this, which is minus x squared plus 2x, then plus 8, make it 0. And I think, guys, before we have agreement, when it's equals 0, and I don't like this minus, we can divide each and every single term by minus. If you do divide by minus, it will be x squared minus 2x, and here minus 8, yes, equals 0. Now it's easier now to factor 2x minus 4 and x plus 2. So we have 2 x-intercepts. So one of them x equals 4, we change the sign, or minus 2. That's why here, look at this, x-intercept is 4 and 0, minus 2 and 0. How? This way. Okay, so we have 2 x-intercepts. So please don't compare this to this sketch you have here, because I told you before, this is very unrealistic, but it's helpful to visualize the problem, and consequently we can easily recognize the maximum, minimum axis of symmetry, so on and so forth. So axis of symmetry equals x equals, it's obvious, x equals minus b over 2a. In other words, it is x equals the x coordinate of the vertex, which is 1. And this line here will split this parabola for two identical parts, okay? And what we have, concavity, you know, a is minus 1, less than 0, so concave down along all its domain, or from minus infinity to infinity, okay? Or we can concave down for all real numbers, any expression, okay? The only horizontal tangent line, which is this one, the horizontal tangent, and obviously this tangent passes through the point 1 and 9, so it will be y equals 9, which is the y coordinate of the vertex. And here, guys, what is very special about this tangent line, it's horizontal, parallel to the x-axis, its slope is 0, unchangeable, the slope is unchangeable. And here, guys, the extreme value, look at this here. Here we have top, not bottom. So this point is maximum, okay? This maximum occurs when x equals 1, and this maximum equals to 9. So please, this is very delicate and very sensitive concepts to master. The maximum, because we have top, as you see, at x equals 1, so I will write like that. It's maximum max when at x equals 1. So the occurrence of this maximum at x equals 1 and equal to what? Equal to 9. So the extreme maximum, okay, equal to f of 1, which is obviously 9, as you see here. Okay, so again, what is the meaning of that? The meaning of that, if we plug any real number in this function, any real number, so all values will be 9 or less, so 9 is the peak, the maximum. No way to have a value more than 9, and it will occur when x equals 1. Hopefully this is clear for all of us. 0 and c, 0 and c. What is c here? C here is 8, so 0 and 8. Okay? Yes, 0 and 8 is the y-intercept. And here the range. Look, the range, all things less than 9. Because 9 is the maximum and all things less than 9 is the range. So the range here is from minus infinity to 9, and please close the interval here. Why? Because 9 itself is a part of this range. Okay? The interval, okay, the increasing interval, increasing, look at this. This function is increasing over this part, from here minus infinity till, please, don't ever say till 9. No, it's not till 9, it's till 1, because increasing and decreasing with respect to the x-axis, not to anything else, please, okay? So here we have, you know, we have here 1. So it's increasing from minus infinity till 1. Here, closed or open, from minus infinity till 1 open. But when we write minus infinity, we have to keep the interval from that side open. We can't close it when we have infinity or minus infinity, okay? But here is optional to keep it closed or open when it comes to increasing and decreasing. Again, they are decreasing. It's decreasing here over this, decreasing till we reach infinity, if we reach infinity. But we don't say from 9, from 1 to infinity. So from 1 to infinity, 1 to infinity, or open interval 1 to infinity, and here open indeed. And here the end behavior, we know this creature with two tails, and these two tails are going down. So whether x is very big or x very small, the function tails are going to minus infinity. So I will write this using limit form, and this limit, it means limit of x when x going very big goes to minus infinity. Even here I will write the limit of this function f of x when x goes very small, also going to minus infinity. So whether x goes to infinity or to minus infinity, the both tails of this function are going down. And I will move to the next example. Hold on, guys. Okay, for this, guys, I have a, b, and c. So a here is x squared coefficient of 1, b equals minus 8, x coefficient or the middle term coefficient, and here the constant is 12c. And here, guys, the domain, which is minus infinity to infinity, or this fancy r, or this handmade with love r. Okay, again, guys, the term domain means which numbers we can plug in this function, and here we are free to plug in any real number. So maybe a question might jump up to your mind: is there some functions that not accept some values? Of course, there's many. Okay, for instance, this function f of x equals radical x. You can't plug in negative numbers here. So domain sometimes is restricted, but for this sort of functions, the polynomial or this quadratic, you are free to plug in whatever you like. Okay. And here the vertex and the sketch. Vertex equals minus, again, the vertex here is minus b over 2a, along with the image of this guy in this function, minus b over 2a, like this. So minus b over 2a, b is minus 8, so minus b is a. For 8 divided by 2 times 1, which is indeed 4, and we'll plug this 4 in the function f of 4. So it will be, as you see, guys, 4 and minus. So 4 and minus 4, guys, is the vertex of this function. So I will choose to be here. So I will assume that this point here is 4 and minus 4. So here we have the value of 4, okay, and minus 4, the y coordinate. And it will be something like this, guys, passes through 12. I don't care about how accurate is this graph, because I will use it for just to guide me and to visualize some properties of this function. It will be smoother than this. Of course, it's somehow like this, okay? Plus or minus, guys. I don't care about accuracy here. I'm caring about visualizing the problem to find some properties. So x-intercepts. So obviously there's here two x-intercepts. So how to find them? I will take this function, which is x squared minus 8x plus 12. So x squared minus 8x, again, plus 12. I will make it equal 0. I will use the method of factorization. So I will factor this to x minus 6 times x minus 2 equals 0. So we have 2x intercepts. So when x equals 6 or 2, that's why we have these 6 and 0, 2 and 0. Okay, so 2 points or 2x intercepts are there for this function, 6 and 0, 6, 2 and 0, 6 and 0. Okay, so here the axis of symmetry, the axis of symmetry, which is the vertical line that split this parabola like into two identical parts. So the formula like this, it will be x equals, because it's vertical line, so x equals what? Minus b over 2a. You have b, you have a, you can just plug in here. Or to make things more useful, it's the x coordinate of the vertex. So what is the x coordinate of the vertex? X equals 4. Imagine here this vertical line, so, okay, passes through the vertex. Okay, it will split this for two identical parts. Okay, so here the concavity, you know that a one more than 0, so this is concave up. Okay, over its domain, over real numbers, over minus infinity to infinity, or simply you can write concave up or upward, the way you like. Okay, the horizontal asymptote, and there's only one single horizontal asymptote. It's really unique, and it passes through the vertex like this, so it will be y equals 4. What's special about, minus 4. What's special about this? It passes through the vertex. It touches this parabola exactly at the vertex, and its slope equals 0, as you know, guys. Okay, so this one here, y equals minus what? Minus 4. So y equals minus 4 is the only horizontal tangent for this parabola. Okay, here the extreme, we have extreme at the vertex, which is minimum. Look, it's like bottom, not top. So this at x equals, so extreme, it's minimum, in for minimum, at x equals 4 equal to f of 4, which is minus 4. Look, guys, there's a lot of harmony here, so please, we have minimum value occurs at x equals 4 equal to f of 4, which is minus 4. It's like that. So what is the minimum value? If the question, what is the minimum value? The minimum value is minus 4. Occurs at x equals 4. Okay, hopefully this is clear. And here, guys, y-intercept is unique, 0 and c. What is the value of c? 12, I think so. 0 and 12 is the point where this graph passes through the y-axis. Here the range, it's everything less than minus 4. So it's from minus infinity to the minimum value, which is minus 4. So the range from minus infinity till minus 4, and minus 4 is included. So please close the interval here. So the increasing interval, it's obvious that this function is increasing over this subinterval. This part of function is increasing, as you see, right? And it's increasing. The increasing journey started from 4, not minus 4, because we are looking at the x-axis. So the increasing journey started from 4 with respect to x-axis, right? So it's from minus 4 to infinity. So the increasing from minus 4 to infinity, open here indeed, and here optional, because at minus 4 I can make it open or I can make it closed, minus 4 to infinity like this. So you know this is open and this is what? Closed. Whether closed or open, when it comes to increasing and decreasing with this sort of functions, it's fine. And the decreasing interval, look, this function is decreasing over this sub-interval here. As you see, guys, from minus infinity, it's going down, 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 and when it's reached 4, it will reach the minimum value, so decreasing from minus infinity to 4. Okay, so look at this, it's decreasing from minus infinity to 4. You can close the interval here, or from minus infinity to 4 you can open the interval like this. The end behavior, again, this parabola with two tails, and these two tails going up, whether x going extremely big or extremely large. Look at this, how these two tails going like, I don't know, I call them tails today, and I like this name. Okay, I don't know if there is any creature with two tails like this parabola. Okay, so I will write this end behavior in terms of limits. So limit of this f of x, as x goes very big, f goes very big as well. Even here, limit when x goes very small of this function f of x, also infinite. So whether x goes very big or very small, both tails shooting up. Okay, and I will move on straight forward for this example. So hold on, guys. Okay, guys, here we have this quadratic function where a here equals 2 and b equals -3 and c equals 1. So the domain is the most trivial. So this minus infinity, infinity, or this fancy r, or this r. Okay. So I think this are called bold board something. I don't know what sort of writing is that. And here, guys, we have how to find the vertex. The vertex here is 3/2 and along with -1/8. So it's 3/4 minus. How to find that? So the vertex here, guys, is simply minus b over 2a. And you have everything, and f of this guy, which is f of minus b over 2a, the x coordinate, equals, yes, point, minus b over 2a, it will be 3/2. You can just plug in, you have b minus 3 minus b over, it will be 3/4, okay? 3/4, and the y coordinate is -1/8. You can just plug in this 3/4 in your calculator in this function. I will tell you how to plug in, but I will clear this later. So it will be like this: 2, then bracket square. Please here write 3/4, then minus 3 times 3/4, okay, plus 1. Then you will have the result of -1/8, okay, -1/8. So if you plug it like that in your calculator, you will have this answer. Other than that, you have to check the way you plug this in your calculator. So 3/4 -1/8, both are negative. So in the third, it's somehow here, okay, the vertex. Again, I'm not caring here about the accuracy. I need something just to guide me. 3/4, and 3/4 is positive. Minus, no, it's not here to any extent. So 3/4 and -1/8. So it will be somehow here, okay? 3/4 along with -1/8, like that. and at the y-intercept at 1. So it could be something like this, more or less, guys. Okay, of course here it's smoother than this. Somehow this is the vertex, you know, the lowest point in this graph. Yes, and the x-intercept. So the x-intercepts here 1/3 and 1. So how to find this? You know, guys, I have here 3 x squared minus 3 x plus 1. I will make it 0. Then I explained something before in another video, and maybe in this playlist you can find it, to factorization, to normalize. And to normalize means to multiply 3 by 1. So it will be x squared minus 3x. Then here I have, yes, plus 1 equals 0. Then maybe this is factorable easily, so it will be x minus, sorry, here not minus 1, and this is 2, so it will be here 2, sorry, because I will multiply, so this is 2, not 3, sorry. You multiply this by this, then it will be 2, okay? So it will be x minus 2 times x minus 1. So it's minus 1 and minus 2. Then you will divide here by the leading coefficient 3. Then equals 0. Then you have already the zeros. The zeros is 2 over 3. Okay. Along with 1. So sorry. So this is by 2. Here, guys, I think I made mistake here. I will correct this. Okay, then how to normalize? I will multiply this 2 by 1. So it will be x squared minus 3x, then plus 2 equals 0. Then I will factor this easily to x minus 3 and x minus 2, not 3, x minus 2. And x minus 1. Then, guys, we will divide by the leading coefficient, which is here 2, and here 2 as well. Then, you know, guys, I can simplify this to x minus 1 and x minus 1 over 2. You can go to that video of factorization and go to this part, which is how to solve or to factor when the leading coefficient is not 1, by what we call normalizing. Then we have 2 x-intercepts, so x equals 1 or x equals 1 over 2. And we have them here, look, 1 over 2 and 0, 1 and 0. But I will clear this just to make things neat and organized, okay? And hopefully this method of normalizing is really super easy. You can have a look to that method before you even come to this file. So there's 2 x-intercepts, okay. Okay, when the 2 points, so half and 0, 1 and 0. Then the question here, what is the axis of symmetry, which is x equals minus b over 2a, which same as the x-coordinate of the vertex, which is 3 over 4, guys. It's given here 3 over 4. And here concavity, as long as a equals 2 more than 1, so it's concave up along its domain, and the only horizontal tangent, which is y, equals the y coordinate of the vertex, which is minus 1/8, okay, minus 1/8. So, and this is here the horizontal tangent passes through the vertex, which is here the lowest point on the graph. And here what we have, the extreme. So the extreme here is minimum. So occurs when x equals 3 over 4 and the minimum value itself equals to minus 1 over 8. So it's minimum at x equals 3/4 equal to minus 1 over 8, which is the image of this 3 over 4, okay? So we have to distinguish between what is the minimum value, minus 1 over 8, occurs at x equals 3 over 4. Hopefully this is clear. And here guys, y-intercept is 0 with c. And what is c here? C here is 1, so it's 0, 1 is the y-intercept for this function. And the range is whatever more than the y-coordinate of the vertex. So look at this beautiful value here. So the smallest value in the range is minus 1 over 8. So what is the range? The range from minus 1 over 2 over 8 and more. So the range started from minus 1 over 2, close the interval, and more to infinity. So the minimum value in the range is minus 1 over 8 and more. So the increasing interval, so it's obvious here, look at this graph guys, it's increasing from this vertex x coordinate and to infinity over this sub-interval. This function is increasing from 3 over 4, not minus 1 over 8. Don't ever do that, please. So from 3/4 increasing, whether you close the interval 3/4 till infinity, or you can open the interval like this 3/4 going to infinity, and decreasing otherwise. So the opposite way here, if you look at this, it's decreasing here that way, okay? So, and decreasing from minus infinity till we reach this 3/4, okay? So decreasing from minus infinity till 3 over 4 closed, or from minus infinity 3 over 4 open. Both are correct. And behavior, that the both tails of this parabola are going up, okay? So look at this, even if you up from this side up and from this side up. So this function end behavior is infinity, whether x is very small or very big. So the limit of this function f of x as x goes very large is infinity. Even the limit here of this function f of x when x goes very small is infinity as well. So both, okay, tails are going, okay, shooting up, even when x very big or very small, okay? And guys, I will move straight forward to this example here. And what I have here is I have 1 over 2 x squared plus x, then minus 2, okay? We will discuss this thoroughly to find all its properties. Okay, students, look at this example here. We have y equals 1 over 2 x squared plus x minus 2, where a here equals 1 over 2 and b equals 1, where c equals minus 2. So the easiest part is the domain, which is minus infinity to infinity, this fancy r, or I like to add this r for the ones who like with bad handwriting like me. And when it comes, guys, to the vertex equals minus b over 2a, and f of this guy of minus b over 2a, and it will be what? It will be minus 2, so b is 1, so it is the vertex is given minus 1 and minus 5 over 2, but I will show you how. Minus b over 2a, which is minus 1 over 2 times half over 1, which is obviously minus 1, and f of minus 1. And what is f of minus 1? I will show you here how to find f of minus 1. You will plug in 1 over 2 like that, then minus 1 within parentheses, and please the square out, not inside the parentheses, okay? Plus minus 1 with or without brackets, it's fine, minus 2. Then you will have the point of this point here, minus 1 and minus 5 over 2, okay? So it will be minus 1 and minus 5 over 2. I will clear this guy, but I want to show you the calculations and the correct way to write this using your calculator. And here guys, I have the vertex already given here, okay? It's minus 1 and minus 5 over 2, so it's somehow here. Okay, somehow it's in the third quadrant, of course, and it could be like something like this, guys, okay? So, and this is again the vertex of minus 1 and minus 5 over 2, okay? So we have now the vertex in hand, and for the which part now? Yes, the x-intercept. I will use another screen here, guys, to find what we call the x-intercepts. Okay, I have a lot here of math things. I will add page. Okay, now I have a fresh page here. I will write this. There's like pile of fractions. 1 over 2 x squared. It's 1 over 2 x squared plus x minus 2 plus x minus 2 equals 0. And if there's something I don't like about this 1 over 2, so in order to make the life easier, what I will do, I will multiply each and every single guy here by 2. So what I do, I will multiply here by 2, I will multiply here by 2, I will multiply here by 2. It's okay as long as it's 0. So it will be, as you see, guys, x squared plus 2x, okay, then plus 4 equals 0. Hopefully that everything is correct, including the signs. This is minus 4, sorry, not plus 4. I have to correct this. I a bit of like forget how this works. Okay, it's minus 4 like that equals 0. Then I will factor this. So as long as it's equal 0 and you multiply by 2 to make the life easier, zeros will be like as they are. Multiplying by 2 will not change the zeros of this quadratic equation, okay? So it will be x plus 2 times x plus 4 times x minus 2 equals 0. So the roots will be 4 and, sorry, minus 4 and 2. And if we switch back to that file, we will find here that the zeros, minus 4 and 0, 2 and 0, same what we get on that note. Okay, so this is fine. I can move on. Here the axis of symmetry, which is here x equals minus b over 2a, which is same as the x coordinate of the vertex. The x coordinate of the vertex, x equals this guy, which is minus 1 indeed. So x equals minus 1 is the vertical line passes through the vertex and split this beautiful parabola like to two identical parts. Okay, so here guys we have the axis of symmetry concavity. Of course a is 1 over 2, it's less than 1 but it's positive, so it's concave up, and this is obvious. Look, it is concave up indeed. And here the horizontal tangent, and not only horizontal, it's the only horizontal tangent, which is the line like touch this graph and it's exactly its lowest point, which is y equals minus 5 over 2. So y equals minus 5 over 2 is the only horizontal tangent for this parabola, taking in consideration that this parabola in fact possesses infinitely many tangents. One of them is horizontal, and the only horizontal one is this one, which is y equals minus 5 over 2, which is the y coordinate of this vertex. Okay, what next? Here the y-intercept, this is 0c. What is the value of c here? If you plug in 0 here, 0 here, so it will be obviously minus 2. So 0c is the point where this parabola intersects the y-axis 0 along with minus 2, the range. The range is the y coordinate of the vertex and above. So you know that the lowest point here is minus 5 over 2. And whatever more than this and more is the range. And what is the range here? Minus 5 over 2 to infinity. This is open and this is closed indeed. So the range is the minimum value and whatever more. Okay. And here the increasing interval. Yes, look at this parabola. It's increasing over this part here. This part is increasing. Not from minus 5 over 2, but from minus 1 till infinity. So from minus 1 up to infinity, this function is increasing. And from minus infinity till that minus 1, this function is decreasing. And whether you make the interval here from the side of minus 1 open or closed, both are accepted, both are correct. Okay, or here you can make it like that, from minus 1 to infinity, even this one here, or from even this one here, from minus infinity to minus 1, open is fine, or closed. Okay, and here guys the end behavior. So whether end behavior, so as x goes to infinity or as x goes to minus infinity, in both cases f goes to infinity, or you can simply use the limit notation. It's already used maybe in the previous example. You can have a look. You can use limit or you can use this. Because here I told you again guys, this creature with two tails, and these two tails are shooting up to infinity. Okay guys, here the next very example I have here is 3x squared. So a here equals 3, where b equals minus 5, and lastly c equals 2. Okay guys, for this example, the domain, we are done with that. The minus infinity to infinity, or this fancy R, or this r. It's the same, okay? It's very understandable, it's very common in mathematics. Every mathematician will understand this directly. Okay, so the vertex here is given. It's not given, but I already calculated in advance just to guide you. But how to find the vertex? To find the vertex, we need this form. You know, vertex is ordered pair, so it's minus b over 2a along with f of this guy of minus b over 2a, okay? And you have a and b, you can use them. So minus b over 2a, you can use your calculator. B here given minus 5, and we have minus over 2a, so it will be 5 over 6 in total, 5 over 6 along with minus 1 over 12. So how to reach this minus 1 over 12? I will tell you how to write this in your calculator, but I will clear that later to give myself more room. So it will be here f of 5 over 6, okay, equals 3. Then it will be here 5 over 6 all to the power of 2 minus 5 times 5 over 6 plus 2, and if you do calculate this, it will be undoubtedly minus 1 over what? Over 12. As I told you, I will clear this just to give myself more room. Okay, so here guys, we have the vertex. So I will switch to another platform to find the x-intercept, but in total what I will do here, I will take this 3, I will take this over 3 x squared minus 5x plus 2, I will make it equal 0. I will solve it here and we'll be back to that file again. I think, okay, I have to charge this device. Okay. Yes, done. Okay. And so again, what I have here, I have 3x squared minus 5x plus 2. So it is 3x squared minus 5x minus 5x plus 2 and equals 0. I will use the method of normalization, something I already invited before in another video. You can find it here. So what I will do, I will multiply the leading coefficient by the constant term. So it will be, as you see guys, it will be x squared minus 5x plus 6 equals 0. By the way, multiplying the leading coefficient by the constant term, then we will divide by the leading coefficient. It will not change the zeros, okay? So this is very factorable. So it will be x minus what? X minus 3 along with x minus 2 equals 0. But what we will do now, I will divide each guy here by the leading coefficient of a 3. So I will divide here by 3. I will divide here by 3. It will be x minus 1 times x minus 2 over 3. I am not looking for the factors. I'm looking for the zeros. And doing this will not change the zeros of the original equation. So the zeros here will be 1 and 2 over 3. Or, 2 over 3. So the zeros 1 or 2 over 3. That's why if we come back to this, the x-intercept is 1 with 0, 2 over 3 with 0. And you can fill in the solution from this blank here, okay? So we have now the x-intercepts, now the axis of symmetry. So the axis of symmetry is the x-coordinate of the vertex. So it will be x equals minus b over 2a, which is simply x equals, we have the vertex already. The vertex, it found before 5 over 6 and minus 1 over 12. So it will be x equals 5 over 6. Allow me to sketch this here. Okay. So it's the vertex here is 5 over 6, which is positive, and it is in this quadrant. Sorry. It's here somehow. Okay. Five over 6, it's here. So I will assume that this is the vertex, which is 5 over 6 along with 5 over 6, sorry. So this is 6 along with minus 1 over 12, minus 1 over 12. So this is in the fourth quadrant, as you know, guys. And somehow, students, it will be like this. This is the vertex, so this is fine. This will guide me to find the properties of this parabola. And now the axis of symmetry will be x equals 5 over 6, which is the x-coordinate of this vertex, okay, 5 over 6. Okay, and the horizontal tangent will be the y-coordinate. So here it will be y equals minus 1 over what? Minus 1 over 12, not 2, minus 1 over 12. Okay, and this is the only horizontal tangent for this function. Okay, so here the y-intercept, which is 0, c, and in this case it will be 0 and 2, because c is 2, 0, 2. And what next? The range. The range started from the lowest y value, the smallest y value, which is minus 1 over 12 to infinity. So it's like this. This is the range, okay? The range from the lowest y ever and more. So the range, of course, minus 1 over 12 included to infinity. So please, this interval here is closed, not open like that. Okay? And here the increasing interval, so it's increasing, is from 5 over 6 to infinity. Look, this portion is increasing. Okay? This portion is increasing, and the increasing journey started on the x-axis from 5 over 6. So here there's, it's a bit flexible, so you can use closed or open interval. So here I have 5 over 6 till infinity, or 5 over 6 open interval till this is both correct, and it's decreasing on the complementary of that, which is, you see, this portion decreasing, and the journey of decreasing ends at 5 over what? Over 6. So it's decreasing, okay, from minus infinity till we reach 5 over 6 closed or open, minus infinity, 5 over 6 open. You see the style of these brackets. The end behavior, this creature with two tails shooting to infinity. So whether x goes to infinity or x goes to minus infinity, f goes to infinity in both cases, okay? Or you can use the limit notation. You can find it like in the previous examples, how to implement the limit notation to express the end behavior of this function. And moving straight forward to the very next example here, it's very interesting. Hold on guys. Okay, so here guys we have this quadratic function a equals 1, b equals -6, and c equals 9. And here we are done with domain, this R or this fancy R or this handwriting with love R, it's fine. And here guys the vertex, okay, vertex here, the formula of vertex is -b over 2a for the x coordinates, and f of this -b over 2a for the y coordinate. So it will be 3 and f of 3, which is obvious. You plug in 3 here. If you plug in 3 here, you will end up with this. It's given here just to ease your life. I have here 3 and 0 is the vertex. And here's something very special about this function, that the vertex itself lies on the x-axis, so, and it's open up like that. And this is what, guys, this is 3 and 0. So very nice, very special vertex. I like it. So here guys, x-intercept, so x-intercept here, so we will take this x squared minus 6x plus 9, make it equal 0. I'll switch into another platform to give myself more room. So what I have here again, I have x squared minus 6x plus 9 equals 0. This is very, very common. We call it, we can factor this to two identical parentheses, x minus 3, or we can simply make it like this, x minus 3 to the power of 2 equals 0. And here x equals 3. All these things you can find in a video, or maybe on this playlist or another one under the umbrella, the title of factorization whatsoever. So this quadratic function has one root, which is 3 with multiplicity 2. It means it's repeated. It's 3 and 3. Does that make sense? Yes, of course, this root is repeated. That's why, guys, this function is bouncing on the x-axis at this point 3 and 0. So we call this sort of intersection between the graph and the x-axis of bouncing, okay? This is how we call it. And the x-axis of symmetry here, x equals minus b over 2a, which is 3, the x-coordinate of the vertex. So it is indeed like this, minus b over 2a, which is here x equals 3. It's obvious that this vertical line passes through the vertex, will split this parabola for two identical parts. And here, guys, concavity, it's indeed concave up over its domain. And the only horizontal tangent, and this horizontal tangent is very special, it's y equals the x-axis, which is here y equals 0. So y equals the x-coordinate, the y-coordinate, sorry, of the vertex. Y equals 0, it's same as x-axis. So the x-axis here is the only horizontal tangent for this parabola. Okay. And here, guys, here the extreme here, which is the lowest point on this parabola, is the vertex, which is 3 and 0. So its minimum, so minimum value at x equals 3 equal to f of 3, which is indeed 0. So if the question, what is the minimum value? The minimum value is 0, occurs at x equals 3. And here, guys, what I have, the y-intercept is 0 with 0c, and what is c here? C is 9, right? So it will be 0, 9. And here, what is the range? The range will start from the minimum value, which is 0 till infinity, and closed interval here. So the range which started from the smallest value for this function ever to infinity, and the increasing interval. So it's obvious this portion here, this half, is increasing, and increasing not from 0 but from 3. So it's increasing. The increasing journey started from 3 to infinity, or open interval 3 to infinity, like that, and decreasing on the complementary, so from minus infinity to 3 closed, or from minus infinity to 3 open. Both are fine, both are correct. The end behavior, so it's like this creature with two tails, and these two tails shooting up. So the function going to infinity, I will use the limit way to express the end behavior of this. So I will write here limit f of x. When x goes to infinity, it means how this function behave when x very large. It's going to infinity. And here limit when x goes to minus infinity of this function f of x, it's going to infinity as well. And I will move straight forward to this example number 10. Here I have minus x squared minus x plus 4. So hold on, guys. Okay, here I have this minus x squared minus 4x minus 4, and here, guys, a equals minus 1, b equals minus 4, and c equals minus 4 as well. So the domain here is minus infinity up to infinity. This fancy r or this handmade r all represent the same thing of set of all real numbers. And here the vertex is minus b over 2a, and here f of this minus b over 2a. So equals minus b over 2a, b is minus 4 over 2a, so it will be minus 2, and f of what? F of minus 2. You can use your calculator to find f of minus 2, and obviously f of minus 2 here is 0. The way you plug it in here, so you will keep this minus, then minus 2 squared like this, please, parenthesis, okay, on the minus thing, and the square above out these parentheses, okay, then minus 4 times minus 2, and here I have minus 4, and you will end up with 0. Other than that, then will be something wrong with the way you enter that in your calculator. So the answer here will be this point of this beautiful vertex of minus 2 and 0. So the vertex lies on the x-axis here, minus 2 and 0, and this function is open, so downward or concave down, and this is the vertex of minus 2 and 0. Of course, the graph is much more beautiful than that. It's like symmetric. You know, this is handmade with love. And here, what we have here, x-intercept. So for x-intercepts, guys, I will switch into this blank to give myself more room. And what I have here, I have minus x squared minus 4x minus 4 equals 0. As long as things equal 0, you can multiply the whole equation by 0. And the zeros will be the same. Plus 4x plus 4 equals 0. You can factor this to x plus 2 and x plus 2 equals 0, and the 0 will be repeated, minus 2 and minus 2. That's why one time enough. We call this 0 of multiplicity 2. It means that it's repeated 2 times. Or you can make this x plus 2 squared equals 0, which means x equals minus 2. We have one single real root, or with multiplicity 2, or two repeated roots, the way you like. Okay, so here we have minus 2 and 0 is the vertex here, and the axis of symmetry will be x equals minus b over 2a, which is the x coordinate of this vertex of minus 2. So this is, guys, here is the axis of symmetry, okay, for this parabola. Okay, this line here that split this for 2 equal parts and passes through the vertex. The horizontal tangent, and the only horizontal tangent here, equals the y coordinates of this vertex. And here, look at this vertex, the y coordinate is 0. So it will be y equals 0, the only horizontal tangent for this parabola. What next here? The extreme value. The extreme value here is maximum. Look, this is like top, not bottom. So this is maximum. So max for maximum occurs at x equals minus 2 and equal to f of minus 2, which is 0. Okay, so this is the maximum value. So here, guys, the y-intercept, which is 0 with c, which is in this case 0 with minus 4, is the y-intercept. And here the range. The range is everything below the maximum value. So the maximum value is 0. What is below from minus infinity to that 0? So the range here, everything less than mine is 0. So 0 included. So 0 and whatever below. Okay, here the increasing interval. So obviously, so this function is increasing from minus infinity, and the journey of increasing will finish here when x equals minus 2. Okay, so it's increasing from minus infinity, from minus infinity to minus 2, and the interval here closed or open, minus infinity to minus 2 closed is fine. Both, open, this is open, or closed, it's fine. And it's decreasing on the complementary, so it's from minus 2 to infinity, or minus 2 open to infinity. It's same when it comes to increasing and decreasing. And look at this, guys, here, the journey of decreasing starting here, not at 0, but with respect to x-axis at minus 2, right? At minus 2, and forever the function is decreasing, as you see. And here the end behavior, this creature with 2 tails, and these 2 tails diving like down to minus infinity. So I will write this in using limit form. So the function f of x, when x goes to infinity, going to minus infinity, is diving down, okay? And here the limit of this function f of x, when x goes to minus infinity, going to minus infinity as well. So regardless again, guys, regardless how this function, the x goes whether too large or too small, these 2 tails are diving down to minus infinity. Okay, here, guys, I have this example. I will leave this number 11 for you guys to practice. Okay, hopefully it will be useful. Okay, here guys I have this x squared plus 2, so this is very nice. And why here, what I have here, I have a equals 1 and there's no x, so b equals 0 and c equals 2. So it's special because of this, like middle term coefficient is 0, there is no x, it means b is 0. Okay, and the domain as usual from minus infinity to infinity, or r all, or this handmade r. Okay, the set of all real numbers. And here guys the vertex here is minus b over 2a, and f of this guy minus b over 2a, which is indeed 0 and f of 0, and obviously here f of 0 is 2, so 0 and 2. Okay, so this is the vertex 0 and 2. It somehow here lies on the y-axis and it's open up like that. And again guys, this graph or this sketch just to guide me. I don't care here about accuracy. Okay, what I have here, I have the axis of symmetry, which is the formula like this: x equals minus b over 2a, which is the x coordinate of the vertex, and the vertex here, as you see guys, is 0 and 2, so it will be x equals 2 is the vertical axis, or this axis of symmetry, and here the horizontal tangent y equals, so the only horizontal tangent is this, it passes through the vertex, so y equals the y coordinate of the vertex, which is here 2, so it will be y equals 2. Okay, y equals 2. And when it comes to the extreme value, so the extreme here, look, the extreme value here is minimum, because we have like lowest point, it's not top point, so the lowest point in this curve is 0, 2, which means that it is minimum value. Minimum occurs at x equals 0. Okay, minimum value at x equals 0 equal to y equals f of 0, which is 2. So the minimum value occurs at x equals 0, and this minimum value is 2. Yes, 0 and 2. Okay, this is fine. Okay, and guys, when it comes to y-intercept, which is 0 and c, and what is c here? C is 2, so it will be 0 and 2. It's obvious, guys. 0 and 2 is the y-intercept, and here the range. The range started from the minimum value and up, so 2 to infinity. Okay, so look here, vertex is vital in this graph. It reveals a lot. So 2 to infinity, 2 of course included to infinity, and here the increasing interval, it's increasing over this half or this part, which started from 0 to infinity. So it's increasing from 0 to infinity or open interval at 0 to infinity, both correct, both fine, and decreasing otherwise from minus infinity to 0 closed or minus infinity to 0 open. And the end behavior, you know guys, these two tails are shooting up whether x goes to infinity or minus infinity. I will write this using limit form. When x goes to infinity equals infinity, and here the behavior of this function f of x when x goes very small to minus infinity equals infinity as well. Okay, next guys, I have this example. There's a few left, we will deal with them. Okay, maybe here guys I just forget small detail. So this talking about x-intercept, this number 3. So here there is no x-intercepts. Let me go in details through this. So what I have here, I have x squared plus 2. So if you make this x squared plus 2 equals 0, so one attempt is to move this here, which x squared equals minus 2. And this is very unrealistic, because how come number square, real number square equals minus 2? So that's why it means there is no x-intercepts for this. And here guys, this example here, I have minus x squared minus 5, and here guys a equals minus 1, b equals 0. there is no middle term where c equals minus 5. So for the domain game from minus infinity to infinity, or this fancy R or this handmade R, okay, here the vertex and the sketch vertex here will be minus b over 2a, the x coordinate, and the y coordinate f of this guy, f of minus b over 2a, and you have b, you have everything. So it will be obviously 0 and minus 5. So this is the vertex, 0 and minus 5. It's somehow here, and this function is concave down because a is minus 1 less than 0, and what I will write here, 0 and minus 5. Okay guys, so x-intercept. So obviously there's no x-intercept. I will discuss this in more details. Okay, so what I have minus x squared minus 5 equals 0. What you can do, you can move minus 5 to other side. So minus x squared equals 5. So you can multiply here or divide by minus 1, and here by minus 1. Again, we are encounter with this strange thing of x squared equals minus 5, and there's no real number. If you square it, you will end up with something negative. So there's no solution for this. It means, so there is no x intercepts here. Okay, again here the axis of symmetry, which is the x coordinate of the vertex, which is x equals minus b over 2a. This is something you can calculate. X equals 0, and here concavity, of course, down. Okay, because the leading coefficient a is negative. The only horizontal tangent line, which is equals y, equals the y coordinates of the vertex. So y equals minus 5. Look at this here. We have here tangent, horizontal tangent, of course. The graph, you know, this is handmade, so you have to lower your expectations when it comes to accuracy. So look at this. So y equals what? Minus 5. This is the only horizontal tangent for this. So here the extreme value, look, this extreme value here is top point. So top point, it's maximum occurs at x equals x equals 0, equal to f of 0 which is minus 5. So the maximum value ever for this function is minus 5. Whatever you plug in this function, any number, any real number, you will never ever encounter with something greater than minus 5. Anything will be less than minus 5, less than. So minus 5 is the maximum here, okay? And y-intercept is 0 and c, and obviously this is 0 along with minus 5. And when it comes to the range here is minus 5 and less, so all things less than minus 5. But how we will write this here as interval, so it will be from minus infinity to minus 5, of course closed interval, so it means that the range, any real number equals minus 5 or less. And here guys, the increasing, you see this increasing journey here from minus infinity ascending to 0. Okay, from minus infinity to 0, this function is ascending or increasing. So increasing from minus infinity to 0, closed or open from minus infinity to 0 like this. Okay, and decreasing complementary for this, and the decreasing here starting from this, okay, from this point here and to infinity. So from 0 to infinity, this function is decreasing or descending, the way you like. So from 0 to infinity or open at 0 to infinity, this function is decreasing. And here the end behavior, and we can see this parabola with two tails, they are shooting down, so it's going to minus infinity. I will write this using the limit expression. So limit f of x as x goes to infinity equals minus infinity, same wise limit f of x when x goes very small equals minus infinity as well. So here it means that whether x going very, very big or very, very small, in both cases the values of this function will dive into very, very small values to minus infinity. Okay, and here guys I have this, we call this pure quadratic. It's only 2x squared, there's no linear part, no constant part. So this is very simple. A here equals equals 2. So B equals 0 and C equal, maybe that's why we call it pure quadratic, because there is no linear part, no constant term. It's very nice, very simple, and very beautiful quadratic function to deal with. Okay, so again and again guys, the domain unchangeable, minus infinity to infinity, or this fancy R, or this hand made R. So when it comes to the vertex, which is minus b over 2a, and f of this guy, f of minus b over 2a, so it will be simply minus b over 2a, which is 0, and f of that, f of 0, which is obviously 0 and 0, right? So this is 0. So here, yes, the origin itself is the vertex. So this point here, we call it the origin, and it's also the vertex for this parabola. And here the x-intercept. So x-intercepts, I will make this 0, so 2x squared. So yes, 2x squared equals 0. You can divide by 2. So x squared equals 0. Apply square root, then x equals 0 indeed. So we have one single root here, or this root repeated, the multiplicity is 2. So the vertex here is 0 and 0. So this is when it comes to x-intercept, that's why it's 0, 0, as you see here guys. So the axis of symmetry x equals minus b over 2a, which is the x coordinate of the vertex. It means x equals 0, which is y axis. So here guys, the vertex is the y-axis itself. So the y-axis here split this parabola to two identical or similar parts. So this is really very special here. And concavity, of course, up over the whole, the entire real numbers, because the leading coefficient is 2, which is more than 0 positive, up or upward. Okay, here the horizontal tangent, and the only horizontal tangent here, y equals the y coordinate of the vertex, which is 0, which is x-axis. So the axis of symmetry is the y-axis, the horizontal tangent, which occurs at the lowest point here on this graph, which is the x-axis itself, y equals 0. And here the extreme, which is the lowest point here, minimum, because the lowest point on this curve is 0, 0. So we have minimum, of course, minimum occurs at x equals 0, equal to what? To f of this, which is 0, right? Which is the y coordinate of this vertex. And here y-intercept here is 0 as well. So y equals 0, or you can call this point 0 and 0 as well, 0 and c. C here is 0. So 0, 0 is very special here. It's the y-intercept, it's the x-intercept, it's the vertex, it's the minimum point or the lowest point in this graph. And here the range. The range is the maximum point or the maximum value for this function is 0, and the range whatever less than this 0. So it goes from minus infinity to the 0, okay? 0 is the maximum. So the range here as interval from minus infinity to 0, of course closed, because 0 itself is a part of this range. And here the increasing interval. So obviously this function, or the journey of increasing here, going from this 0 to, okay, for the entire like positive x-axis. So from 0 to infinity, the function is ascending. So 0 to infinity like that, or open here to infinity like that. Both are fine, both correct. And decreasing in the complementary of this 0 to infinity, which means from minus infinity to 0, or from minus infinity to 0 open, both are fine. And the end behavior, you know, this function is shooting up, whether x goes to infinity or to the minus infinity, which means whether x going to infinity or to minus infinity, the function is going extremely, unboundedly large. Okay, so you can write this as like that: f goes to infinity as x goes to infinity, and here f goes to infinity as well as x goes to minus infinity. And or you can use the limit notation. It's available maybe in the previous example or the previous one. It's available, super easy. And here, students, we have the last example on this list, minus 3x squared. Of course, I will give the graph. The graph will be like this. The vertex is 0, 0. There's a lot of similarity between this and the previous one. Okay, the vertex is 0, 0, and here the vertex is a maximum. So for the rest of details, I will leave it for you, students. Thank you for watching. Please print out this give it a try using very conventional way, pencil, pen, and please keep tablets away. This is my advice for you guys. Enjoy your time and bye for now.